children, welcome back to our computer class. Today we are going to discuss a new chapter, our third chapter, computational thinking and getting started with Python. Today's topics are introduction to problem solving, steps of problem solving, algorithm, and flowchart. Computer help us solve problems. However, before a problem can be tackled, we need to understand the problem and the ways to solve it. Irrespective of the language being used, the first and foremost thing while writing a program is to analyze the problem well and try to solve it in a logical manner. The process of writing a program is called programming. We are writing set of instructions to solve a problem involving data processing. These instructions must be executed by the computer to solve the program. Before we start writing a program, the steps for solving the problem should be clear in our mind. Precise step-by-step instructions should be inputted to the computer system to solve the problem. Proper and flawless execution of any task inside a computer depends on how correctly and precisely we define the problem, design a solution, and implement the solution using a programming language. Thus, problem solving is a process of identifying a problem, developing an algorithm for the identified problem, and finally implementing the algorithm to develop a computer program. When problems are straightforward and easy, we can easily find the solution. But a complex problem requires a methodological approach to find the right solution. In other words, we have to apply problem solving techniques. Problem solving techniques begin with the precise identification of the problem and ends with a complex working solution in terms of a program or software. Key steps required for solving a problem using a computer are analyzing a problem, developing an algorithm, coding, testing, and debugging. First step is analyzing a problem. It is important to clearly understand a problem before we begin to find a solution for it. If we are not clear as to which is to be solved, we may end up developing a program which may not solve our purpose. Thus, we need to read and analyze the problem statement carefully in order to list the principal components of the problem and decide the core functionalities that our solution should have. By analyzing a problem, we would be able to figure out what are the inputs that our program should accept and the outputs that it should be produced. This step is developing an algorithm. It is essential to devise a solution before writing a program code for a given problem. The solution is represented in natural language and is called an algorithm. For a given problem, more than one algorithm is possible, and we have to select the most suitable solution. The algorithm is discussed in the successive session. Step is coding. After finalizing the algorithm, we need to convert the algorithm into a format which can be understood by the computer to generate the desired solution. Different high-level programming languages can be used for writing a program. It is equally important to record the details of the coding procedures followed and document the solution. This is helpful when revisiting the program at the later stage. Next step is testing and debugging. The program created should be tested on various parameters. The program should meet the requirements of the user. It must respond within the expected time. It should be generate correct output for all possible input. Software industries follows standardized testing methods like unit and component test, integration testing, system testing, and acceptance testing while developing complex applications. Is to ensure that the software meets all the business and technical requirements and works as expected. The errors on defects found in the testing phases are debugged or rectified, and the program is again tested. Once the software application has been developed, tested, and delivered to the user, still problems in terms of functioning can be come up and need to be resolved for the time to time. We discussed about algorithm in the step 2, developing an algorithm. Now we are going to discuss more about algorithm. Algorithm is the step-by-step process written in natural language. Example, steps required for an activity, ride a car. For that, first step, move the car out of the garage, sit in the driver's seat in the car, start ignition using car's key, press clutches and place the gear in correct position, accelerate and start driving, use brakes whenever need to stop on reaching the destination. The activity ride a car, we write step by step process in natural language. In 7th step, we represent the activity ride a car. Like this, we can represent anything, any activity in step by step process. See another example. To write the algorithm to find GCD of two numbers 45 and 54. GCD is the largest number that divides both the given number. For that, first step is find the numbers that divides the given numbers. The divisor of 45 is 1, 3, 5, 9, 15 and 45. Divisors of 54 is 1, 2, 3, 6, 9, 18, 27 and 54. Then find the largest common number from these two lists. Therefore, GCD of 45 and 54 is 9. Now we can discuss about need for algorithm. What is the need of algorithm? A programmer writes a program to instruct the computer to do certain tasks as desired. The computer then follows the steps written in the program code. Therefore, programmer first prepares a roadmap of the program to be written before actually rewriting the code. Without a roadmap, the programmer may not be able to clearly visualize the instructions to be written and may end up developing a program which may not work as expected. Such a roadmap is nothing but the algorithm, which is the building block of a computer program. Purpose of using algorithm is to increase reliability, accuracy and efficiency of obtaining solutions. Characteristics of a good algorithm. Precision, the steps that precisely started or defined. Uniqueness, results of each steps are uniquely defined and only depend on the input and result of the preceding step. Finiteness, the algorithm always stops after a finite number of steps. Input, algorithm receives some input. Output, the algorithm produces some output also. While writing algorithm, it is required to clearly identify the input to be taken from the user, processing or computation to be performed to get the desired result, the output desired by the user. Next is flowcharts. Flowcharts are the pictorial representation of a task or algorithm. It is defined as a visual representation of the sequence of steps and decision needed to perform a process or task. They are used to represent how a program works. A flowchart depicts the flow of a program. Charts are used in analyzing, designing, documenting, or managing a process or program. Specific parts of a flowchart represent specific parts of your code. There are mainly 5 symbols used in the flowchart. First symbol is oval shape. It represents start or end point. Next one is arrow. A line is a connector that shows relationship between the representative shapes. Then next is parallelogram. Parallelogram represents input or output. Next one is rectangle. Rectangle represents a process. Next one is diamond shape. A diamond indicates a decision. If there is a question as answer yes or no, it will be represented by decision. We can discuss about the example of flowchart. The question is draw a flowchart to find average of 3 numbers. First we can use start symbol, that means oval shape. Then we have to input 3 numbers. That input we want to represent in parallelogram. Input A, B and C. Next is process. We want to find the average of A, B and C. That is we written in the rectangle. Average equal to A plus B plus C divided by 3. Next is we want to give output. That output is written in the parallelogram as print average. After that we want to stop the execution. That stop we will write in the oval shape. Did you clear everything? It is an example for another flowchart. Draw a flowchart and write the Python code to get input a name and print hello with name. The flowchart is first we want to start, then input name. Input means it is in parallelogram. Here there is no processing. We getting the input and outputting the name input also. That time we can take another parallelogram and output hello name, then end. Here Python code is the in right side. You can see that first we want to input. Input means name equal to input what is your name. That time the which thing we are typing that will get into the name. Then print hello plus name. Then it will print as hello. Then which name you type in it, it will display the hello with name. Next we are going to discuss about pseudocode. Pseudocode is used to express our logic independent of any programming language. As the name suggested, it is not a real code. It is an informal approach in English-like language about how we will solve a problem. There are no rules associated with writing a pseudocode. It could be a list of instructions in English-like language or in any programming language. Pseudocode should not be a specific coding language. Draft the structure of your code be understandable to humans. Example, write a pseudocode that reads marks of 10 students and display average of marks. The first step, set total to 0, set mark counter to 1. While mark counter is less than or equal to 10, input the next mark. Add the marks into the total. Set the class average by dividing total by 10. Display the class average. This is the pseudocode for treats the marks of 10 students and display the average of marks. We can discuss another example for pseudocode along with Python code. Your question is to get a name as input and then print this name with hello. The pseudocode is input name, output hello name. The Python code will be name equal to input what is your name, then print hello along with name, that means plus name. Did you understand, children? I think you understand what all things we discussed today. Thank you. Have a nice day.